Greetings, this is Mrs. Gillihan once again. This is Math 1, International Math 1. We are looking at task 1.10, and this is from your homework directly from the RSG packet. We're actually going to look at problem number 8, and they have given us a table here, and our instructions are this. Each of the tables below represents a geometric sequence. Find the missing terms in the sequence and show your method. Now, we have explored this up, down, left, right in class, but if you get home and you're working on your homework and you're finding that you're having some struggles, it's always good to see it another way and to have some strategies while working at home. So we see this XY table, and we have a sequence of 4 numbers, or a sequence of 4. The first number in the sequence is 2, and the fourth number in the sequence is 54. And we have 2 missing blanks, and that's our task, is to figure out what goes into those blanks. And so, you can guess and check this all day long, and you can kind of look for a pattern, or you can look for something along the way to kind of give you some clues, and we talked about those in class. But there is pretty much a guaranteed algorithm if you're willing to study it and if you're willing to think about exactly what is happening here. And let's start to kind of analyze what exactly is going on. In a geometric sequence, we know that we start with 2 and we repeatedly multiply by a common ratio. So 2 times the common ratio would give us the second term, times that same common ratio would give us the third term, times the same common ratio would give us the fourth term. And so we're going to represent that right now graphically with, of course, the letter R is what we use to represent that common ratio. And we would have to, in order to go from 2 to 54, we would have to multiply by that common ratio 3 times. So 2 times R times R times R equals 54. And of course we can, as always, when we have that kind of a situation, we can actually place that into an equation. And so what I have done here is I have just taken my visual here, 2 times R times R times R equals 54, and I've placed it into an equation here, 2 times R times R times R equals 54. And as we know, when we have an equation with only one variable, we do have 3 R's, but they're all the same, we can figure out what that variable is. We can solve for that single variable. So let's simplify this a little bit just to make it a little bit more manageable. I am going to rewrite it as 2R to the third power, because R to the third with an exponent of 3 means that we've multiplied by R 3 times. I'm just sort of simplifying that so that I can see this as R to the third power. Okay? And of course we'd use the reverse order of operations, which means I have to get rid of this 2 first when I am solving this equation. So let's go ahead and divide both sides by 2 in order to get rid of that 2. And when I simplify, after using the division property of equality, when I simplify, I'm left with R to the third is the only thing that is left. And of course, 54 divided by 2 gives us a result of 27 here. So now as we look at this, in order to find the common ratio, remember we're looking for that number that is repeatedly multiplied here, I'm kind of looking at this, and I have kind of an idea in my head of what that might be because we've been working with so many different numbers and repeated multiplications. But let's think if we didn't know what the cube root of 27 was. If we didn't know what R times R times R, what same number multiplied by itself 3 times gives us 27, what we would do. Well, we would have to then take the cube root. We have to do the same thing to both sides in order to keep that equation balanced. But if I take the cube root of R cubed, and I know that sounds a little discombobulating there, and then over here if I take the cube root of 27, I could even just put that in my calculator, and the cube root of 27, we end up with 3. So the cube root of R cubed ends up with R, and the cube root of 27, if I needed to use a calculator, I absolutely could, but the cube root of 27 gives us 3. So the common ratio in this case is 3. So if I want to take that common ratio over here and apply it to my table, I can very easily do that by saying 2 times 3, that will give us 6, and then that will go as our second term will be 6. And then I can continue that pattern 6 times 3, because our common ratio over here is 3. 6 times 3 is 18. And so that goes into our empty spot, our third term in the sequence. And we could double check and make sure that 18 times 3 is 54, which it absolutely is. And we have been able to completely fill in this table with a guaranteed strategy over here. Looks a little long, but it actually really does not take much time when you realize how that repeated multiplication helps us to set up the equation.